Artists and scientists alike have as a fundamental goal the description of the world they sense around them. Both are describers and interpreters. Both need an audience. They observe an outer world, but what they are ultimately describing is an inner one. While artists paint or sculpt their mental images, physicists give form to their mental images in much the same way through the symbols and equations of mathematics. Physicists and artists are not so different after all. Both are convinced they are representing reality in some form or other. One thing is certain, the mind plays a central role in both their enterprises. Science does not simply explain reality, it sometimes creates reality. We human beings, because of the nature of our genetic development, are simply not equipped mentally to understand all levels of natural phenomena. As a result, we have created not one but 6 different realities. One of these realities is the world as we know and sense it, the world of our direct experience. It is the world we actually live in. Most of us think that this is the only reality, but is simply not so. We can understand this world so well because our minds and bodies have actually developed in it. In a sense, our brains have their present form precisely so that this world can be thought about and conceptualized. The other 5 worlds or realities contain physical phenomena that are beyond our direct perception. We have not lived in these worlds, nor can we ever. It is a tribute to the persistence of our curiosity and to our intellectual abilities that we are still able to make sense of these worlds, but we have to do some really fancy creating in order to do so. As we continue our studies of the world around us, we bring these realities together as seamlessly as possible and call the result contemporary physics. The laws and theories of physics are maps of a reality that we will probably never fully understand. These laws and theories are very useful for getting around in that reality, but we must never confuse them with the reality itself. For one thing, the laws and theories are constantly changing, whereas the reality presumably is not. For example, physicists have developed a complex and picturesque hierarchy of elementary particles, ranging down to a small group of what are called quarks and leptons, which they consider more fundamental than all the others. My teacher, David Finkelstein, used to say of those fascinating objects called quarks that they were small particles emitted by physicists. It could very well turn out that elementary particles have no reality at all other than the fact that they were created by physicists to help them explain reality at some deep inner level. The limitations imposed by the nature of our minds. I believe our minds are equipped with a set of conceptual structures, which, for lack of a more appropriate phrase, I will lump together and call common sense. Common sense guides the way we think about the world around us. When coupled with careful observation and logical reasoning, it is more than adequate for developing scientific laws and theories that describe and explain most of the phenomena we are familiar with. These laws and theories then form a map of what most of us call reality, the concept of symmetry, which is the study of changes that cannot be detected. Relativity deals with the question of whether there are certain fundamental features of our own existence that we cannot, in principle, measure or detect. It turns out that there are. When artists view the world, they magnify and even glorify the subjective aspects of their point of view. That is the sense in which they make the commonplace unusual. Physicists, on the other hand, try to eliminate the subjective as much as possible. Physical description dwells on the things that we all agree upon and attempts to eliminate, or carefully control, individual perspectives intruding on our descriptions of nature. Position and momentum, where an object is located and how fast it is moving. Actually, momentum is the product of an object's mass and its velocity, are two essential descriptive quantities of Newtonian mechanics. In the new theory, they could no longer be independently and simultaneously measured with arbitrary precision. This meant that their role in a description of microscopic reality would change substantially. What was extremely disturbing was the fact that the behavior of a gas, or liquid or solid, was characterized by a property, called irreversibility, that Newton's equations could neither predict nor describe. If you put a drop of cream into your coffee, it eventually spreads out to fill the entire cup. You would never expect to see the cream, once it was mixed into your coffee, gathering itself together and reforming as a single drop. Yet according to Newton's mechanics, as time goes on, individual molecules show no preference for any particular direction in their motions and could, therefore, eventually return to their starting position. If, for example, someone could instantaneously turn every cream molecule around, that should certainly cause the cream to reverse its motion and head back to reform the single drop in the center of the cup. Nevertheless, this sort of thing never happens. Most notable of these was the late 19th century development, by the Austrian physicist Ludwig Boltzmann, of a theory that started out with Newton's reversible mechanics and, rather miraculously, produced the correct irreversible behavior of the gas. Boltzmann's theory created a tremendous controversy and was rejected by some of the most eminent scientists of the day. Probability is a mathematical language peculiarly appropriate for dealing with ignorance. The notion of chaos arose from the discovery that there are certain apparently simple systems, describable by Newtonian law, whose behavior seems to lack the predictability that characterizes that law. Many things in life are known, or considered, to be unpredictable, but those phenomena usually contain at their core an element of chance or randomness, which we believe accounts for that unpredictability. Chaos, however, is a term reserved for systems that do not have any element of chance in their behavior. Chaos is sometimes referred to as deterministic unpredictability, a kind of oxymoron. It is deterministic in the sense that you can solve the equation that describes the behavior of the system, and therefore any given starting point determines a unique path of subsequent behavior. To sum up: 1. I can't know my own state of motion, relativity. 2. Although I can predict the general behavior of a complex macroscopic system, I must relate it to the behavior of the constituent microscopic parts by probabilities, because complete knowledge at the microscopic level is impossible to obtain. Statistical mechanics. 3. I can't ever know as much about an atomic system as I can about a classical system, quantum mechanics. 4. I can't even predict the behavior of many simple classical systems, chaos. All this lack of knowledge worries many people. But this is only because they have built up a set of unreasonable expectations about the world based on their many successes in using physics to deal with everyday phenomena. In fact, they have been unbelievably fortunate.
Thank you for watching. Please subscribe.